Alright, so we're going to work on the next graph that we have to make, which is going to be this one here, here. So we worked on a graph similar to this in one class. We didn't do too much, but basically this is a bit of a different graph, and we're going to start over from the beginning, and we're going to work through how to make this graph. So one of the big things that we're going to be doing in this code is finding the indices, like always. That's one of the more important parts for these kind of workshops. And the next thing is we are going to use some logical operators to check when a player hit a ball over 95 miles per hour. And we also want to constrain this to when a ball is hit in play. So basically, if a player hit like a foul ball, we're not looking at that. And you know, if you're a baseball fan, I wanted to take that part out, because if you hit a foul ball, a lot of the time it's not going to be good contact. So, you know, a bit random there, but we want to check when a player hit a ball in play. So, you know, it results in an out or a hit, and we want to check if the ball was hit over 95 miles per hour. And with how we make our code, we can adjust just one line of code. That's why I say X miles per hour, and we can change our entire figure just by changing one line of code to something like, you know, 100 miles per hour or something like that. And then the other thing that's important is automating our xtick labels, so we don't have to type any of these names out. And the last thing is our formatting for this ytick axis. We want to format all of these numbers here so we can basically append this percentage sign. Alright, so let's get started. We're gonna make this graph. Well, that's the goal. Alright, so what I've done so far, let's make this bigger. So what I've done so far is I've done the importing process so far, and you know, I'm not going to show you that part because all of you should know how to do it now. So just t, that's our table, equals read table. These two dots, again, that takes us back one directory. So our directory, let's go to it. Where did I put it? Where did I put it? Here. Okay, so here's our code, where it's highlighted right now, right here. That's the file. And those two dots, they take us back one directory. And then I told MATLAB to go into my data folder, and then I selected this file right here. Okay. Alright, so first thing we're gonna do here is I never can decide where to put this. I guess I'll put it down here. Oh, you know what might be better? Hold on, sorry, I know this is off the cuff. Oops, you go there, and you go here. Yeah, we'll keep it like that. Okay. So one of the first things we're going to do here is find the unique players that we have. So I think we did this in the last video too, actually, if I remember right. Or we did it in class. But we have a lot of players here. This is just for the Angels team, but there's still a lot of players in this worksheet, so we want to basically use a function called unique to find every single unique player on the team, and then we're going to delete some of them that we don't really want to look at for this exercise. So let's call this names. Then we're going to use our unique function, and then we're going to do t.playerName. So remember, t, that is our table over here, and then .playerName, that's going to access this column here called playerName. And the unique function, I think by default, it sorts in alphabetical order. If it's in numeric order, like if you're sorting integers, it might do it by numeric order. So, you know, going from 0, 1, 2, 3, and so on. Alright, so we have that. Let's open that up in our workspace. Open names. Here we go. So this is currently a cell array. So we have 22 rows in here for our 22 players. If I'm in my workspace and I type in names of 1, then you see that this is displayed as a cell. We can tell that with the curly brackets that we see here. And sometimes this is okay, but a lot of the time we actually want to use a string instead, because we need a string to use some logical operators that we're going to use later on. such as the equality logical operator that we've used a few times so far. I'll actually move this over here. Maybe that's a bit better. Yeah, that's good. Okay, so I don't want to have all of these players in here. I want to take some of them out, just so we don't have to type too much. And some of them, no offense, I don't really care about them. Wow, that's kind of mean. Okay, let's remove some of them. So we want to access this cell array that's called names. And now we're going to basically use array addressing to address which of these rows that we want to take out. And because this is a one-dimensional vector and we only want to look at different values in here and multiple different values, we're going to wrap this inside of brackets. We talked about this in the workshop as well. Okay, so let's do 2 to 5. I don't want these players from 2 to 5. And then from 7 to 10, I don't want them, so 7 to 10. And then 14 to 18. And then player number 22. So remember, if man, deja vu, I swear. I guess, yeah, I only talked about this in the workshop, I think, but if I didn't have these brackets here, so if I didn't have these brackets, we're going to get an error right now. It says index in position 2 has exceeded our array bound. So basically we have that error because we're telling MATLAB essentially that we have a 4-dimensional array here. This is 1 dimension, this is 2 dimensions, so like a matrix. This is 3 dimensions, like a multi-dimensional array with those different layers. And this is 4 dimensions. At least I don't think we have that. So to just address only the rows that we want to take out, we have to wrap all of this in brackets. And this will constrain us. All of this here is just 1 dimension. So we're accessing different rows in this array. So if I run our code now, you're going to see this is going to go from 22 by 1 to, I think, 8 by 1. So we run that, and yeah, I forgot to actually delete it. Okay, so let's actually delete it. So we're going to say equals to empty brackets. Do that, run it, and then there we go. This changed to only 8 players. Cool. Okay, now we're going to do some conversions. So we're going to convert the player name column to a string. And I guess we didn't convert this one here. I guess we don't need to have it as a string later on. When I made the script is a few days ago, so I forget. And then we're also going to convert the column called launch speed into a double, so numbers. Because I think right now that's a cell array as well. It's like column 54. So you can see that we have those single apostrophes. That means that this is a cell array. So we're going to convert player name to a string. That's column 6. And then launch speed to a double, so we can use logical operators for those columns later on. Alright, let's do it. So t dot player names, and we're going to say equals to string. That's to convert this from a cell array to a string of t dot player name. So we're basically just updating that column. Let's type this right now, class of t dot player name. This will say it's a cell. There you go. I'm going to run this now, and let's check this again. And okay, I think I know what happened there. Let's do t dot player name. Oh, jeez, it's tripping out. There we go, t dot player name. Okay, now let's do class t dot player name, and it's a string. And you can see this updated to having these double apostrophes. Alright, next thing, we're going to convert launch speed column, or the launch speed column, to a double. So currently that's a cell array as well. We'll check it though. Class of t dot launch speed. That's a cell array. Let's convert it. So t dot launch speed equals string to double. So it's currently a cell array, but we can still use this function called string to double to convert it from a cell array into a double or a numeric array. and we're going to do t dot launch speed, run that, check it again, and now we have a double that shows up. Alright, so now we're going to get into the kind of the meat of our code here. So the first thing we're going to do is specify our target miles per hour for how hard someone basically is going to hit a ball. And in this case, later on, we're going to also specify for it being in play. And then after that, we're going to see how often they do that in terms of a percentage. So I'll just call this MPH, and I'm going to set this equal to 95. And again, we're making this variable, so later on, if I want to change this to a different target, I can just change this one line here, and I don't have to change all these other lines down below when I'm going to reference this line again. So if I just typed on all of these lines down here, whatever miles per hour I wanted to use, if I want to change it later on, I would have to change all of those lines. That's a hassle. I'd rather just change this one line where these other lines reference that variable MPH. Okay, so now we're at the meat of our stuff. So let's find all of the rows that are not a number for launch speed. So let's go to launch speed once again. Here we go. Right, I'm actually going to go back here. I'm going to comment this line out when we converted it from a cell to a double. So before we had rows in here that were called null. When we convert this to a double, that changes to not a number. So just to make a note of that. So right now we're going to find all of the rows, and this is a bit different than what we did in the workshop, but I found this to be a more logical and easier method. So we're going to find all of the rows that are not a number, so like all of these rows here. And then, so we're going to find those indices, basically, or what the row number is. And then we're going to delete all of those rows because I don't care about them. I only first want to look at all of the rows when there is some kind of contact. So basically when we have some number in all of these rows here. If it's not a number, don't care about it. I'm going to delete it. So let's call this variable nan. We'll actually call it nan-ind for indices because that's actually not. We're actually not really finding the indices here. I'll explain. So let's do nan is equal to is nan. That's a function. It's a logical function. So once I type in here t dot launch speed, and let's run this. If I open this up in the workspace, you see that we have answers of 0s and 1 because again, is nan, that is a logical function. So our result is going to be a logical result, which is a 0 and a 1. So 0s, they mean false, a 1 means true. If I pull this out here, basically you can think of it like we're saying we're going to look at this row, or this column, I mean, launch speed, and we're going to ask MATLAB to tell me if this is not a number for row by row. This first row, that's a number, so we get an answer false here. Same thing for row 2, same thing for row 3. Row 4, that says not a number, so that's going to give us an answer of true because, yep, it's true, this is not a number, so it gives us a 1. Now, if I was actually finding the indices for this, I would use the find function that we've used in the past. So if I do find, and then I run this, now we actually get these specific indices or rows when we have a value of not a number in this column. So we see row 4, that's not a number. That's what we see here. And then rows 6 through 10, we see that as well. So you can use find if you want. It's up to you. If you just kind of want to visualize it like this, but we don't really need to use that function find. It's really just going to slow down our script a bit. So I'm just going to leave it as this logical result that we see here. Alright, next thing, we are going to now delete the rows that are not a number. So again, you could have used the find function and you already have those indices or all of those rows when it's not a number. But we don't need that because we have, when we just use that logical operator for is nan, we can utilize the results for that to kind of use these true values as our as we can use them for array addressing. So this is when there's a 1, we can kind of use that as array addressing to do something. So in this case, we're going to want to delete the rows when this is true. So basically, MATLAB will go, oh, row 4, that was true. And if I tell MATLAB to delete stuff, it's going to delete all of these rows where there's a 1, which again means true. So to kind of recap, I want to delete all of these rows when it says not a number. We just use our function isNaN to get a logical result if a row in here has NaN. So when there's a 1, that means it does have a value of NaN, and we can delete all of those rows now. So I'm going to do T, that's our table, and I'm going to say NaN, and then comma, colon. So we're looking at our table T, and then for the rows, so I'm using array addressing now, I said NaN, which is, what we just had here. And again, we're using these values of 1 to basically kind of represent that it's going to be array addressing for like row 4, and then rows 6 through 10, and so on. And then we also want to delete all of the columns. So, I want to delete this entire row, which, includes all of these columns for that respective row. And I want to delete all of this stuff, and so on. Okay, so we'll set that equal to empty brackets so we can delete it. And watch before your eyes as all of this stuff goes away when we have NaN. And you can also look up here. So currently we have 9,114 rows. That's going to cut down to I think it's 2,000 something. Let's run it. 2,626. And now you see that there's nothing in here in this row or this column that says NaN. All of the rows that we have now, they have some number. Alright, so the next thing that we're going to do is find the indices for each player. Alright, so we have 8 players. I want to find all of the indices for each respective player so I can get all of the data for that player. And I could even restrict it to well, yeah, we just want the rows now actually, so forget what I was saying. So we're going to find the indices for each player, okay? And we're going to use the find function. And like I kind of hinted at earlier, we could have used find up here, but I said that it would actually slow down our computation. Now for what we're doing here, it's, our data set actually, believe it or not, it's not that big. So the differences in speed, if you used find in this function up here, or this line of code or not, it's not going to be that big of a difference. And even down here, I'm actually going to show you 2 different methods. So method 1 is the slow way, which is when we use find. And method 2 will be basically the same kind of method that we used up here when we basically just used a logical operator, and we kind of use that for our array addressing. So I'm actually going to show you the differences in speed between these 2 methods, and again, it's not a huge difference, but it's something to keep in mind for your coding, throughout your life. Alright, so let's find the indices for each player using find. So we're going to do this slower method first. So I'm going to make this a cell array because I want, because each player is most likely going to have a different amount of indices for them. So basically, one player, they might appear in this table 500 times. Another player might show up 300 times. Those are different lengths, and if we want a matrix in MATLAB, all of our columns need to have the same amount of rows. But that rule does not apply to a cell array. So I could have a cell array with all of our cells, and each of those cells can contain their own array, and they can all be different lengths. So that's why we're making a cell array here. Okay, so I have player underscore id for indices and 1 for the first player. Let's do t.playerName. I'll add in the find function in a second. So t.playerName, we want to look at that column 6. And we want to find when that is equal to names of 1. So our first player, so Joe Adele. Alright, let's run this. Let's open it. There we go. So we have 2,626 values here. But this is a logical array, because currently that's all we have here. You know, we have this logical equality right here. And so we're going to get values of either zeros or ones. So remember, 1 means true. So on row 6 in our table, Joe Adele should show up. And there he is. So this is kind of the method that we used above up here. But let's use the find function now. Because that's what we're used to so far in the class. And it's a bit easier to visualize this stuff too. So if I go back, now this is giving us all of the rows when Joe Adele shows up. So 6, 31, 45. And you can, you know, quickly find this stuff at a glance instead of scrolling through that logical array. So 6 and what was it? 31, 45. Let's check. 31, Joe Adele. 45, Joe Adele. Looks good. Alright, now we're going to do this for the other 7 players that we have. So let's paste that. So this is why I'm using my text editor here. It's a lot faster. Okay, so we have 8 players. So I'm creating 8 cells for them. And then over here for our array addressing, let's also modify that. Okay, there we go. And now if I run this, we're going to have 8 cells for player indices. And because we used the find function, it's actually giving us the rows for each of these players. So you also see that we have different lengths here as well. So we have 132 for the first player, that's Joe Adele, and 283 for the second player, that's David Fletcher. And you can keep going on like that. Alright, so we have all of our indices. Okay, so I'm just looking at some of my comments here. Some of these were just for myself. Okay, so now we're going to find the when we have a miles per hour value or a launch speed value that's greater or equal than, and in this case right now it's set to 95 miles per hour. That's what we set up here on line 24. Alright, so we're going to use our find function again, which again, we don't necessarily have to use it, but for the sake of this video, I'm going to use it again right now because it's a bit easier to visualize stuff. So I'm going to call this player underscore gr for greater than, I guess I could put GRE, greater than or equal to x, for x being x miles per hour. And I'm going to make this a cell array as well because I want to find all of the times when there's a player or when each player has hit a ball greater than or equal to x miles per hour. Okay, so this is, I'm kind of doing this step by step. So I'm first checking when a player has hit a ball over x miles per hour, and then below I'm going to at least attempt to then also add on a constraint that they hit the ball in play. So, you know, before when I was doing one of the workshops, there were some comments of not trying to do everything on one line, and I totally get that. You know, this right here, this block of code, it's not too bad, you know, for each line. We're really using just 2 things at once, or I guess a few more. We're using the find function, we're using a logical operator, and, you know, technically we're doing array addressing too. But if we're going to add on some more stuff here, that could be a lot of things on one line of code, and it can be hard to digest. So if we're doing one thing here, which is first finding if a player hit a ball greater than or equal to x miles per hour, and then after that we try to add on another constraint of having the ball hit in play, you're going to see that we actually run into a bit of an issue, which you could remedy, but trying to fix this issue is really, it just adds on even more time, and can lead to more confusion as well for sure. So in the end, we're actually going to write a lot of this stuff on just one line of code to see when a player hit a ball over x miles per hour and hit a ball in play. But first off, let's do this right now. Find when a player hit a ball greater than or equal to x miles per hour. or equal to. Okay. So for our first player, we're going to say find when t.launch speed. And because we're doing this for our first player, I want to do array addressing. So player underscore int 1, that's for our first player. Then we're going to check when that was greater than or equal to, in this case, 95 miles per hour. Let me make this bigger so you can read it a bit better. So we're saying find when the launch speed for player 1 here, I'm using all of their indices for player 1, find when that was greater than or equal to miles per hour, which is our variable that we made up here, which is equal to 95. Okay, and if I go back over here, column 54, so for Joe Adele, right, we're seeing, I think he started on row 6. We're going to look at this value here, and we're going to have MATLAB run a logical operation to say, is this greater than or equal to 95 miles per hour? No, it's not. So our first answer for this right now should be a 0. Let's find out. Okay, so we have 32 by 1. So we have 32 answers in here, and we have one column. Now, he showed up more often than 32 times, right? But here we actually use the find function, so I kind of misspoke. We use the find function. So this is telling us that Joe Adele actually hit a ball greater than or equal to 95 miles per hour 32 times. Let's check this out. So, and this is when the confusion actually starts here. We get a value of 2. And basically, you know, when we use the find function, it gives us... I stopped all my comments here. So when we use the find function, it gives us the row when something is true. So this gives us a value of 2. So what does that really mean, right? You might think, okay, that's the second row in our table here, but that's not the case. Our second row in our table here is for Jemai Jones, not Joe Adele. So you have to be really, understand what's going on with your code here. And in this case, if we look at our code again, it's saying find when t.launch speed for this player index is greater than or equal to 95 miles per hour. So that number of 2, it really means the second row for Joe Adele's player indices. So that basically means this index right here and this array that we made for player indices. So really, it actually means row 31 in our table. So if I go to row 31 in our table, we see that it is Joe Adele. And if I go to column 54, that was hit 104 miles per hour, 0.7. So that's greater than or equal to 95 miles per hour, so that's true. And because we used a find function, MATLAB spits out what that index is. But again, let's kind of recap this because you need to really, make sure that you understand this part. So when we ran this code right here for this line, and we open this up, you see that our first result here is the number 2. And when we use the find function, it's going to give us the row when something was true. In this case, it gave us the row when t.launch speed for these player indices when that was greater than or equal to miles per hour. So this value of 2 is referencing in here, this right here, this second row, which is a value of 31. So if we, peel back that next layer, that value of 31, when we made these player indices, that's when we looked at our table. And so that's row 31 on our table, which again was for Joe Adele, and he hit the ball 104.7 miles per hour. Okay, so there's a lot of things going on there. So it's almost, not Inception, but you're going kind of layer by layer, and you really need to make sure that you're keeping track of what's going on. So, in my opinion, in this instance, it can actually lead to more confusion because, you see that value of 2 for this line of code and you go, oh, okay, that's the second row in T, right? Because I typed out t.launchSpeed, but you need to remember that you also used array addressing for those player indices, so that 2 really stood for the second row for those player indices, and this 31 represents the 31st row in our table. So again, I personally think when you do it step by step, at least for something like this, it can actually lead to more confusion. Okay, so let me check my comment here and see if I missed anything. Okay, yeah, so I covered it all. Of course, I have some grammar errors too. Okay, so basically, also what I have here is, you know, for, I think a lot of people, at first you might see that number 2 and you would think, okay, that's the row that we have in our table T. And again, that's not correct. So basically, I'm going to show you that we have incorrect values here. So if you ran this line of code and you're like, oh yeah, okay, cool, this is all my values here for how often, or actually in this case, yeah, it's the rows for when Joe Odell hit a ball over 95 miles per hour. So you might think, okay, yeah, that's right. But we can actually check to see that this is actually incorrect. So let's do that. So we'll say, prove that the above line of code is not good. I don't know. It leads to confusion, basically. So if I do player underscore GREX boo, because it sucks, don't really name it like this bad. But basically, I'm going to use this. So remember, these give us indices, and you know, again, they're really giving us indices for our player indices here, which also then references indices for the table. But if you ran this code and you just thought, okay, it gave me the index for the table, that's going to be incorrect. So if I do t.launchSpeed, and then I can actually just type in here player GREX, I need to do 1, and then we're going to open this up. So let's open this up, and we're going to get values. You know, some of them just by chance are over 95 miles per hour, but look how many of these aren't over 95 miles per hour. So that's showing you that this is really incorrect. So again, it's really referencing the second index, you know, here, which is 31, which is really referencing the 31st row in T. So there's a lot of things going on once again. So instead of doing this, I'm going to comment these out too, because we don't need them. We're going to do all of that on just one line of code. So basically, we don't have to worry about kind of keeping track of what index, you know, corresponds to what. We'll call this correct method to find values of MPH greater than or equal to X MPH. Okay, there we go. So right now this code will actually show us, because we're gonna kind of check that this is correct too. I'm writing code to actually display the miles per hour per hit, and we want to make sure that it's greater than or equal to 95 miles per hour. So let's call this player GRE X MPH. Well, actually, we'll just put X here. So, you know, I commented this out, so it's not going to impact anything. But this is going to be the kind of correct method now. So I'm going to do t.launchSpeed. Okay, so I want to basically look at this column here, but I want to look at this column for Joe Odell. So I'm actually just going to redo the array addressing that we did before. So find t.playerName equals names of 1. So this is going to be for our first player. We know just because we know that it's Joe Adele. And then so basically I have t.launch speed find t.player name equals names of 1. Right now we're just looking at all of the rows in this column that are for our first player. But I also want to add on the constraint of when this is greater than or equal to x miles per hour. So we're going to say and. That's a logical operator as well. So and we want to check when t.launch speed for this first player is greater than or equal to mph. Okay, now we run this. Let's open this up. Okay, so we have 32 values again. But all of these values in here, they're greater than 95 miles per hour. Let's change this, I don't know, to something even harder. Let's do like 102. Let's see if he had a few over 102. Okay, so now it's only 21, and all of these are over 102. Dang, Joe Adele, he had a terrible season, but he hit the ball hard sometimes. 105, we have 17 times. I'm just kind of marveling at this now. 111 right here. Nice. Alright, so that's how we do that. Okay. And let's go down here. So let me make this bigger so you can read it a bit better. And we're going to go over again what we did. So we have t.launch speed. We're looking at that column for the launch speed. And then I'm finding all of the indices for our first player right here. So we're getting all of the rows for our first player, and we're using array addressing to look at just the column called launch speed. And then we are adding on, and we want to then check when, for these rows, for our first player, when t.launch speed is equal to or greater than miles per hour, which right now it's set to 95. And then it's going to give us all of those values for when it was greater than or equal to 95 miles per hour. Okay, sorry, my computer keeps bugging out. I think there's an issue with OBS in my keyboard for like shortcuts. So when I type stuff, sometimes I'll type like one letter and it'll go like that. It's really annoying. It only happens when I make these videos though. So I think there's an issue with OBS. Okay, so anyways, that's why we need to write out this entire line of code and kind of, almost in a way, kind of redefine or refine the indices per player in here to avoid the issue that we had on this line of code here that we proved in this line of code here. Okay, so we have it for one player now, so let's get it for the other 8. Yep. I've been debating making a video about Vim for my classes, but maybe no one really cares. Okay, there we go. So let's run this now. This is other stuff I was checking out. Okay, here we go. Alright, so we have a 1x8 cell for all of our different players. So remember, this was basically finding or giving us the values for all of our players when they hit a ball over 95 miles per hour. So if we check our first one here, they're all over 95 miles per hour. Check our second player, all over 95 miles per hour. So it goes like that. And you didn't have to have this part here. You didn't have to have this. I just did that to actually look and confirm that all of the values that we got were values that were greater than or equal to 95 miles per hour. Alright, so next thing, what do we have now? Okay, so now we're going to find the percentage of the time that a ball was hit hard. I'm thinking of 95 miles per hour, and that's hard contact for baseball. So we want to find the percentage of time that a ball was hit at or above X miles per hour. Okay, so we have all the values, right? So we have the length, but now we want to find this as a percentage for all of the times that they made contact with the ball. So sometimes they didn't hit it over 95 miles per hour, we want to find the percentage of time when they actually do hit it over 95 miles per hour. Find percentage of time ball hit greater than or equal to X miles per hour. So I'm going to call this perc MPH for percentage miles per hour. And because I'm just finding a percentage for each player here, I can just make this a column vector or a row vector, it doesn't matter. So first off, I need to find the amount of times that they hit a ball over X miles per hour. That's basically what we see here. 32 times for our first player, 34 times second player, 48 times third player, and so on. So to do this, we're going to use our length command, or you can use numel for this vector. So we have player GREX. We want to do it for the first player. Yeah, I'm just looking at my code there. I didn't specify that in my code. Maybe I have an issue over here. Yeah. Okay, so I need to do it for my first player. And then we're going to do this divided by length of player indices for our first player. Then we're going to do times 100 to get a percentage. Okay, so we have the amount of times they hit a ball over X miles per hour. And then this second part right here, is finding the length for all of the times a player shows up in our table. And remember, we took out the times or the rows when it said not a number. So every single row in our main table, the player hit the ball in some form. Alright, let's run that. And let's open it up. Perc MPH. So 24% of the time for Joe Adele. Now let's do this for our other players. Let's go here. And go over here. There we go. Let's run that. Take a look at what we have. 24%, 11%. 16, 15, 11, 12, 16, 23. Okay. Oh, yep, I thought it looked a little weird. I forgot to get this one here. Kept all of those at once. I thought it was weird only because of Mike Trout. That's the only reason why I noticed that. Oops, sorry. Okay, there we go. Let's run this again. Oh, I accidentally changed something up here. Okay, a lot of stuff going on. I figured out the issue. It's something that I never had an issue with before. I'm not even really sure how I did it, but one time I accidentally went to the top of my document, and I guess unknowingly I changed this. So the issue was that this says Angels 2021, not Angels 2020, which is the spreadsheet that we have. So that's why we had that issue, and I changed a lot of my numbers in my script. You see here, this was a 2 before. Yeah, it was a 2 before, and now it's a 3. This should be 95, it's a 96. This should be 1 to 8, not 2 to 9. So, a lot of issues there. Never had that happen before, but anyways. This is where we left off, so I basically took my script from before and I copy and pasted it, so... So some of these are different. We just had this called GRE before, but again, this is a slightly different script only in respect to what some variables are called. But anyway, so this is where we left off, and if we run this now, we're gonna get this, which is also incorrect. So also my script before, I had a bit of a mistake. Before, I actually didn't have any array addressing here. It just looked like this. If I run that, then you'll see that we get different values here for the percentage. So if I do this, our percentages go down a lot. But this is also incorrect array addressing. My mind is fried. Blame the time, I don't know. So we need to fix this too. Player gr x mph, that's a cell array. You can see that right here. So we need to change our array addressing to use curly braces. Okay, so let's do this. And take you, and we'll do 1 to 8. Now if we run this, you'll see our percentages. They're going to go up quite a lot. Alright, and this is good. Alright, looking good now. Who's player... Yeah, player 6 is Mike Trout, I believe. That looks good. Let's make sure. Open names. You see, I'm also doing sanity checks. Now, I know not everyone's going to be a baseball fan, but when you're working on your code for the project, you should do sanity checks to make sure that, you know, whatever result you have, actually think about it. Does this make sense? And if it doesn't, then something probably went wrong. Alright. So we have the percentage of time that a ball was hit over at or above X miles per hour. Alright, so the next thing that we have to do is find the percentage of time that a ball was hit in play over X miles per hour. So right now it's just any time that a player has contact with the ball. But we want to change this to when a ball is in play. Just do 1%. So find percentage of time ball hit in play at or above X mph. Okay, so now we're going to find the percentage of time that a ball was hit in play at or above X miles per hour. So, there can be a bit of an issue again, or there's a potential to have another mistake similar to the mistake that some people may have for what we did here on line 52. When basically, when we were, finding the times when someone hit a ball greater than 95 miles per hour, if we weren't careful with our indices, we might actually be looking at the wrong row. And that same kind of mistake can happen down here. So something that you should always do is actually check the results that you have. So, you might just type all of this out. Let me make it bigger. So you might type all of this out and you might just run it and it runs fine and you think it's okay and it's good. But you really need to do that sanity check again and make sure that what you have makes sense. So I called this P and PH play wrong for percentage of miles per hour in play, and it's wrong. So basically this, it might look okay at first, where we're going to find the indices for T.BB type. That means the type of ball that was in play. And basically we want to look at all the times the ball was in play other than the value of null. So when it's null, that means, the ball is not in play. So here, what we have, at least at face value, is we're finding all of the rows in our table T when the ball was in play, and we're looking at the indices for player 1. So all of this here, all of the stuff that's highlighted right now, it looks like we're finding the indices for when the ball is in play for player 1. And then we're adding on an argument for this player 1, find when the launch speed was greater than or equal to mph. So that looks fine, right? So if we run our code, I think I already did, but whatever. If we run our code and we look at this in our workspace, this one here, you see that we're looking at indices of 2, 4, 18, and so on. Let me move it over. Okay, I'll just take you out over here. Okay, so we're looking at indices of, I'll close this to 2, 4, 18, 23, and so on. So let's actually make sure that the things that we set in this line of code are correct. So let's go to the type of ball that's in play. I forget what it is off the top of my head. Okay, column 24. So basically it has to be anything that's other than null. So let's look at row 2. Okay, it's a line drive. That's good. Now let's check column 54. Row 2, that's over 95 miles per hour. So that looks good. Now let's check, or there's actually an issue already, right? We're on row 2. but we were trying to do this for player number 1. And remember, player number 1, he did not start on row 2. He started on, I think, row 6. Let's check it out. So player IND. So player number 1, he started on row 6. So we're already running into that issue that we're looking at the wrong rows once again. So these indices, they correspond not to the table, but to a different part for our indices. So we really need to be careful of that. So again, it's the same kind of thing here that we ran into up here earlier on this line here. So really, this is the second index in P_IND for our first player. So really, this should say, really, the first time that this line of code is true is actually row 31 in our table. So let's check that out now. Row 31. Let's first make sure that we have the correct player. So row 31, Joe Adele. There he is. That's our first player in names. Let's check that too. There he is, Joe Adele. Okay, so that's good. Now let's check the let's check if it was in play. 24. It was a line drive. And now let's check what the speed was. So column 54. It was 104.7. So this is good. The next one is index 4, and again in our player index here. So this is row 58 in our table T. Let's check it out. Go back over here to column 6. Make sure it's the right player. What was it? 58. Okay, 58. Let's go to 58. That's Joe Adele. We're good. Right there, row 58. Let's check if it's in play. There's a line drive again. Good. Let's go to 54. And 103.9. Okay, so that's good. So, you really got to be careful of this index thing. And again, this is why you want to always check your results. Make sure that they look correct. Alright, so I'm just going to comment this line out because it can lead to those issues that I just showed you. And let's go here to this line. Okay, so this is the correct way to kind of go about it. And this is similar to what we did in all of these lines here, where we kind of did a lot of things just on one line. By the way, if my computer's messing up, it's really annoying me. It's still being an issue with OBS. So bear with me if I go insane. So on this line of code, what we're doing is we're saying find, so give me the rows in our main table T when T.playerName is equal to names of 1. So this is, kind of this right here is basically finding the indices for our first player. And then we're adding on the constraint that, so you need to satisfy this, okay? Our player name needs to be equal to that first player, Joe Adele. And in addition to that, T.BB_type needs to not be equal to null. So basically that means that it has to be anything other than null for a ball that's in play. And also, T.launchSpeed must be greater than or equal to MPH. So this actually isn't too bad of a line of code if you ask me. We're just telling MATLAB, make sure that T.playerName, let me scroll up a bit. Okay, yeah. So we're just telling MATLAB that, make sure that we have our first player, make sure that the ball is in play, and make sure that our launch speed is greater than or equal to MPH. So what do we want to do there? We want to make sure that this is actually valid. So I can still use my find command here if I want. And if we run that and we go to, let's open this up. So MPH play. Let's take it out here again. Okay, let's open this up. Okay, here. So first one is row 31. And that's actually what we saw before, right? That was what we just did. So, here, let's actually comment this. Let's run that part again. So open p underscore mph play. Wrong. Okay. So remember, this told us it was our second row, but this is our second row in our player indices, which is the 31st row in our table, and that's what this shows as well. And then the second one is row 4. That's row 4 in our player indices. That's our 58th row. That's also what we see. We'll check one more. The 18th row in our indices here, which is our 595th row in our table, which is what we see here once again. So doing this method, what we just typed out, is going to be a lot easier for us to kind of take a lot of these things in at once. It makes sense, right? Okay, I know this video is getting pretty long, but there's a lot of things in here that I want to make you guys aware of. Okay, so we're going to copy. I'm going to comment that out again. Copy this, do it for other players. There was very good potential for my computer to act weird during this part. So, yeah. Okay, there's that part. Need to do our array addressing here for all of our players. Yep. There's the first time it acted weird. Okay. Alright. Let's run that. And let's open this up. So we don't have it open. Open p underscore mph play. Okay, this gives us all of the indices. You know, like we did before, we could also change this to actually just straight up show us the value right away if we want. I guess I'll do it just to show you guys. So let's do t.launch speed. So we're basically just going to get the launch speed directly here. Go over here, we'll run that. And then once I open this, then we get all of our values here. So all of these are over 95 miles per hour, and they're also in play. So I guess in this case, since we're checking two things at once, it was easier to just check our indices and check it kind of manually. Or we could also put in our second column here if we wanted to show that that it was in play, but we already did all of that. Okay, so what we have to do though is find the percentage, right? So we're going to edit our code here. So let's actually take that out, what we just did, and we also need to go to the end, get rid of those parentheses here. So get rid of these. Also get rid of these. Okay, and now we're gonna type in length. Get this. So we want to find the length of when the player had a ball in play and the launch speed was greater than or equal to mph. So you see I'm looking at my parentheses over here, and they're balanced for over here for the length. Now we also then need to get our percentage, we need to do divided by the length of our indices for that player. We already got the indices before, and we're just finding the length here, so we can reference the indices that we found before. Okay, my computer is bugging out once again. Length of, so we want to do player ind, and we got to do it for all of our players. Okay, I'm going to make this smaller just so I can see the whole line. And there we go. So now we have the amount of times that a player has hit a ball in play greater than or equal to mph, and then we're taking that number and then we're dividing it by the amount of times that a player made contact with a ball. Yeah, I'm just realizing this now. This shouldn't be just the amount of times they made contact with the ball. It should be the amount of times that they hit a ball in play. So let's actually change this again too. It's going to make this even longer. So divided by this should basically just be... Oh man, my computer's just freaking out. I'm just gonna make this easier for me. Let's go back over here. Boy. Okay, delete all that. Okay, I was making sure that I was still recording. Okay, because I refreshed my computer. Okay, so I'm just gonna copy all of this actually. There we go. And I'm gonna paste that in right here. Oh boy. I know you guys won't really be able to read this, but on the left hand side here, we have the amount of times that a player hit a ball in play over 95 miles per hour currently. And then on the right hand side here, we have the amount of times that a player hit a ball in play. So not necessarily over 95 miles per hour, but we want to find the amount of times or the percentage that a player hit a ball in play over 95 miles per hour. So in both cases, you know, the ball is hit in play, but we want to find the amount of time that they hit it over 95 miles per hour when it was hit in play. Last thing we have to do, multiply by 100 so we can get this as a percentage. Now let's run this. Great, I have an issue with my parentheses. Oh yeah, I'm missing one. I'm missing parentheses right here, that's why. Okay, so let's go over here, parentheses. And I'm missing one more actually, so let's do this. So there. Okay, and this is another benefit for my text editor. I can see my parentheses here and where it's balanced out over here. Now it should run. Thank you. And let's take a look at this now. So now we have all of our percentages over here. Which, to sound like a broken record again, this represents the amount of times that, or the percentage that a player hit a ball in play over 95 miles per hour. Okay. And we're doing this for, you know, all of the times that they hit a ball in play. So, hopefully you guys are still watching. I know this is really long now, but now we're at the plotting part. So now we're at the fun part, if there is a fun part. Alright, so let's do this. Oh yeah, let's make this bigger now. Okay, so we're going to make a bar chart, and we're going to do bar of p_mph play. If I just run this now, let's see what we have. Oh, okay. I have this as accelerate. It doesn't need to be accelerate. Let's change this one more time. Yeah, okay. So you see I currently have this as accelerate for my brackets here. I don't need to have it as accelerate though. I was just finding the percentage for each player. So let's use regular parentheses here. And now if I run this, now it should work. Yeah, there you go. Okay, so here is our graph. It took a hell of a long time, right? And that's all it looks like. But we got a bit more to do. Alright, so we have our bar chart, but we also want to see the players here that we have. So let's do that. So we're going to use xtick labels. And I don't want to type out the player name, so all I have to do is type in names, because that's a string array that we made earlier on, which you can see here. And it's going to be in order because this whole entire time we've been keeping everything nice and in order. You know, we have names of 1, names of 2, names of 3, and 1, 2, 3. So we kept everything in order the whole time. Then we're going to have to change the xtick angle so we can actually read all of them. If I run this now, it'll update like that. Looking pretty good so far. Now let's add our Y grid. So I want to have horizontal lines here. So to do that, I'm going to do AX equals GCA. This will access our axis properties. And then I will do AX.YGrid capitalization matters equals on. Okay, now we have our Y grid there. Looks good. And let's put in our title. So we're going to say the percentage of time that a ball is in play and hit over num to string mph miles per hour. Alright, yeah, that looks good. So I have these brackets in here because I'm using a function called num to string to convert our number for mph into a string that can be printed in our title. And then I also have these spaces here so everything is nice and spaced out in our title. So if I run this, then we'll get this. And if I didn't have those spaces, basically 95 would be smushed right next to over and mph. Okay, so there's a title, and last thing we have to do is adjust our xtick format, or our ytick format rather. So remember, we want to put a percent sign next to these numbers. So I'm going to do ytick format. Then I'm going to do percent G, and this is basically like a, maybe I'm wrong here, but I think it's a regular expression. Could be wrong, I don't know the exact word. And this is to basically modify how this is going to look. And basically we want to append a percent sign, so now I'm going to put in a percentage there. And I'm going to close that out, and then we'll run this now. And now we have percent signs there. Alright, so there we go. That took a long time. There were some issues I encountered from my old script throughout the video, so that added on. Alright, so that's the video on how to make this graph. Before we go, let's change a few things just to show the benefit of not hard coding. Let's change mph here to 100 miles per hour. Alright, there you go. See, I only had to change one line of code, and all of this changed for us on the fly, even our title. So David Fletcher, he hardly ever hits a ball over 100 miles per hour when he hits it in play. That's expected. Mike Trout, he's the highest. Also expected. Joe Adell's pretty up there whenever he actually got a hit in 2020. And all of the rest, they look expected as well. You'd maybe think Ohtani would be a bit higher, but had a bit of a rough year last year at some points. I never went over the differences in speed or showed you, but that's okay. It's maybe I'll do that in another video. Let's change one more thing, alright? Let's add in a whole nother player. Let's do that. So, player number 22, I remember, I think that was Taylor Ward, but let's pretend we don't know. Let's take him out. Let's say that I want to include this guy now. Let's run this. And I'll say names of end. And yep, that's Taylor Ward. Okay. So let's say that we want to look at this guy too. All I gotta do here is add him in each time. Put a 9 there. He's the 9th guy. Okay, so we're gonna add him in here too. 9. 9. Add him in here. 9. 9. 9. And here. 9. 9. I'm not speaking German. Alright, there we go. Now let's run this. Bang! There he is. Taylor Ward, he's added in there. Wow, did not expect him actually to be this high. He had a pretty good year, but I don't know he hit the ball that hard as much. Cool though, so you see that's all I had to do. I just had to add in another line of code and for all of those different sections, and I didn't have to explicitly say his name ever. And so, you know, having these big blocks of code, they're kind of a pain in the ass if you want to add more data in there, you know, like another player. And this is when for looping is really going to come in handy, which we're going to learn really soon here. So, yeah, anyways, that took a long time. Let's make this a little more ridiculous. We'll do 110. Some people never hit it over 110. I mean, not too much of a surprise, but yeah. Anyways, that's that. Alright, thanks for watching. I'll see you guys in the next video. I'll make a few more. Alright, see ya.